Hi everyone. In today's class we are going to see about resolution in first order logic. It is a rule of inference used in automated theorem proving and artificial intelligence. In this logic we are going to determine the satisfactory of logical formulas. It extends the resolution principle from propositional logic to the move expressive domain of first order logic, which enable reasoning with quantifiers and predictors. So, in the first order logic, we have two key points. One is unification, another one is a resolution. If I say unification, it is a key concept which helps to prove by resolutions. What is resolution? It is a single inference rule which can efficiently operate on the CNF, or you can say it is a casual form. If I say CNF, again this is a new word. The CNF means conjunctive normal form. It is a sentence which represents as a conjunction of classes which is used to the conjunctive normal form, or you can say it is a CNF. Okay, then what is class? We are saying this effectively operate on CNF model, or you can say it can be used with a casual form, no? So we should know what is a casual form. The casual means disjunction of the literals. It is also called automated sentence, which is used as a class. Sometimes we call this as a unit class. Then we have few steps which to be involved in the resolution. But with the first order logic concept, the very first point is conversion of the facts into the first order logic. First we have to convert all the facts into a first order logic. That's our first step. The second step is convert that first order logic statements into a CNF model. Okay, the third step is we have to negate the statement which needs to prove. It means prove by contradiction. Those statements that negative has to be done with your statements, with the CNF statements. Okay, the last one is here, draw the resolution graph. That is our unification model. So these are the steps will be involved to convert the first order logic by using with your resolution model. Okay, we'll see with an example. Here I took the one real-time example. This is the instance. Okay, John like all kinds of food. The second one, apple and vegetables are the food. Then third statement is anything anyone eats and not killed is food. Okay, the next one is yeah, Anil eats peanut. Okay, and it is still alive. The last statement is Harry eats everything that Anil eats. Okay, so this is the instance. This is the any real-time instance you can consider. Okay, here I consider these five are the known instance for me. I have to prove this John likes peanut. This is the statement what I have to prove. John likes peanut. By using a resolution method, I have to prove this statement. Here, this statement won't be directly concluded here. Okay, John like peanut. That statement is not alive here, but we have to make it by using a resolution method. We'll see one by one. See, the first step is you have to convert all the facts into a first order logic. Okay, our first statement is John likes all kinds of food. So all kinds, you have the keyword as all kinds. So here this is used for the for all. This meaning the sign of this is for all. Okay, all kind of food. So for all, this x is represent what it is. Here this x represent it is a food entity. Okay, and it is likes, it implies that likes John. Here we have to read the statement as John likes x. X is a food, all kind of food. Okay, now you got the statement John is one of the entity. John likes all kind of food. So this is a way how you have to convert the real-time facts into a first order logic. Here we converted first statement. Okay, the next one is what? Apple and vegetable or food. This is a statement. This has to be converted into a first order logic. All the facts or all the instance has to be converted into a first order logic. Here you have apple and vegetables or food. Here the food is the common. The food is a group. Okay, on this group we have one entity that is apple, and on this food we have one more entity that is vegetable. Okay, this is the way how you have to understand the statement. So apple is a group of entities. On this group, food is a group of entity. On this group we have one entity as apple. Okay, on the food we have one entity as apple. Then here we have the sign of and, no. Okay, we have the sign of and. So and is represented by this sign. Okay, then vegetables. We have to say food is also one of the entity of the vegetable. This is also one of the entity of the food. Okay, so this is a food is a group. On this group I am going to represent one entity, that is a vegetable. Okay, so we have converted now into a first order logic. Apple and vegetable or food. Okay, and also represented here. So the second one is also done. The third statement is anything anyone eats and not killed is food. Here anything, anyone. Here you have two statements and two different groups. Anything as well as anyone. No, that's the reason here we have used for all x and one more for all y. Okay, this represent anything and the second one represent the anyone. Okay, so what I have to convey? Anything anyone eats and not killed is a food. So eats, all this, no, anything anyone eats is the first half of the statement. So I put the action word here as a eats for anything as well as anyone. So eats within a bracket x comma y. Here we have the keyword as and, no, so I used this sign. The next not killed. So if I say as a killed, not will represent by this sign, negation sign. Okay, not killed is a food. Okay, so it implies it is a food. Got it? So the third statement is also converted. The fourth one is Anil eats peanut and still alive. Here Anil eats, okay, we have to read like this, no? Anil eats peanut. Okay, the next is again and statement you have, no? Anil eats peanut and this and represent with this sign. Okay, so Anil eats peanut and still alive. So who is alive? Anil. Alright, so within a bracket I have to represent what is the entity name, and here I have to represent what is his group. Okay, alive of Anil. Okay, now we represent the fourth statement also. The last one is Harry eats everything that Anil eats. Okay, so Anil eats x. X is my food. Okay, so for all x, it implies that Anil will eat the x. Whatever the Anil eats, the Harry is also will eat. Okay, that's the meaning of this statement, no? Harry eats everything that Anil eats. You got it? So first I represent what Anil going to eat. Anil eats x. That going to be eaten by the Harry also. So it implies that whatever the Anil eats, it implies that Harry also will eat that food. You got it? Okay, so that's why here I represent first about the Anil, then I represent the Harry, because in the statement it says that whatever Anil eats, that only going to be taken by the Harry. Harry eats everything that Anil eats. Okay, that's the reason first we make what about the Anil, then we implies with a Harry. The next, up to this, what of the instance we have? No, that those 5 statements, all this will be converted as a first order logic. From this known facts, we are predicting 2 more statements. Okay, these are the prediction. These are the 2 predicted statements from the known facts. Here you have 2 statements. What are they? Whatever the skilled, no? we have represent here anything anyone eats and not killed is a food. So whatever the food you are taking, if you are not killed, then it means that you are alive. Okay, you are going to take the food. Okay, if you are not killed, it means that you are alive. That's a one of the predicate statement. Another statement, if you are alive, then it is not killed by any food. Right. So these are the two predictors we have taken from the known instance. Okay. Then what I have to conclude? John likes peanut. So here I represent with a statement. John is the entity. Okay. John likes peanut. Got it. This is what we have to prove with your resolution method. Now the very first step was done. Conversion of the facts into a first order logic. Then the next step is converting that first order logic into a CNF model. Okay, in the second step, no, already we told in the step 2. Okay, after converting the first order logic, no, here we have to convert the first order logic into CNF, which is essentially in the first order logic resolution, because CNF make the resolution proofs which is more easier for us. Okay, so that's the reason we are converting all the first order logic statements into a CNF model. Here all what I have to do is we have to eliminate the implication sign and we have to rewrite the statement. Okay, see here, for all x, food of x, no, that implies likes, John likes that x, John likes the food, right? So this implication has to be removed. If I want to remove this implication sign, no, we have to add two more things here. The first thing is this negation sign. Okay, then second one is, instead of having that implies sign, no, I have to put this or. Okay, if I replace these two instead of this implication, then it's a way to convert the first order logic into the CNF model. Whenever the statement is having the imply sign, then only you have to do. Otherwise, you can keep the same statement here also. How we have the food of apple and food of vegetables, no, the same thing was represented here. If you have the implied sign, then I have to add the negation as well as the or sign on the CNF model. Okay, then likewise I have to convert all the statements here. Okay, so the second step is converting the first order logic into the CNF model. Okay, now we'll see with your third point. The third step is conversion of the first order into a CNF. No, on that we have to move the negation sign, negation inwards, as well as I have to do the I have to write the read statement. Here for all x, you have, it implies with the negation sign, food of x this is or sign, likes, that is John likes the x. Right, here, see here, you have the negation, right, in this statement, no, this is only going to be rewritten. When the negation is having with a whole statement, then that part only going to be replaced. Others remains the same. See here, within a bracket we have the negation sign, so that is going to be removed in this statement. So this is the continuation of the step 2 only. Okay. The next point is, you have to, after converting this, no, you have to rename the variables. This is the important step. The third part, no, we have to rename the variables, or you have to do the standardized variable. You have to use the standardized variable. Okay, so this will be, see here, this is the negation with the eats of x comma y, and it implies with the killed by x, no. So here we have using with the x, y, the same x going to be repeated here and the same y has to be repeated here, no. Instead of that, we are renaming for each category. So each x comma y, here I represent that is with your variables of y comma z. Okay, for this killed I represent with your y, because whatever we represent here, that's going to be replaced here also. Okay, then for the food, the new entity was given, food of z. Okay, the same way in these three statements also I have to do the renaming concept, renaming of the variables. Please remember, we are renaming of the variables. And one more thing, while renaming, no, see, first I have used this for this x as a food. Okay, so whenever I represent the x, it implies with a food only. Okay, then for this eats, no, here we have x comma y. It means what? Harry eats everything that Anil eats. That's the meaning of this statement, no? So that place I have to replace with a new variables. You got my point. Always when I represent the x, it represents only the food. Okay, when I say food, it only the x. Likewise, it will be assumed. The next y and z, x instead of x comma y, I am utilizing with your variables y comma z. Got it? So in this way, we have to represent. We have to introduce the variable. See here, again we are saying the Anil eats x. No, already I used x, y, z up to this statement. So in the next statement, here I used with a w. You can use any variables, but whenever you are representing the same, that variable has to be replaced for a single word. Okay, likewise you have to choose. Killed with a j, so here also g. Then alive with your k, so here also I have used the same. So this is the logic you have to follow, okay, while renaming the variables. The next step is you have to eliminate the extensional instantiation quantifier by the elimination method. So whenever you have the extensional quantifier, that has to be removed. This process is also called Zoclimation. Okay, the next step is you have to drop the universal quantifiers. When you have the quantifiers, that has to be dropped. When you have the universal quantifier, that only will be dropped from the statement in this step. So in this step, what we are doing, we are dropping the all universal quantifiers. Since all the quantifiers are not implicitly quantified, that will be not going to be utilized. So this is a way, in the last step we are following. Okay, after converting this, here what we are doing, all the universal quantifiers are identified, that will be removed from the statement. Luckily in this statement we are not having any universal quantifiers, so we are moving with your next step. Okay, the final step is you have to draw the resolution graph. How I can draw resolution graph? We have the statement which is converted by the CNF model, that has to be related. See what I have to prove, John likes peanut, right? That's a statement we have to prove by the resolution method. Here, instead of proving John like peanut, I am going to take the contradiction statement. John like peanut, that's the way I have to prove. I am going to take the contradiction and says that the contradiction was false. It says that whatever the statement is true is always the true. This is a way how we are going to prove by contradiction method. So John likes peanut, I have to prove. For this statement, the contradiction statement is John doesn't like peanut. Okay, so that is what I have taken here. John doesn't like peanuts. For this, I have to choose which statement is suitable here. John doesn't like peanut. So whatever the food is taking, or which is likes by the John, right? So that x can be the peanut also. If I say represent like this, this all likes and dislikes will be cancelled. Then I am having only the food which is of peanut. So for this statement, again I have to choose which is suitable for to prove this. Okay, so eats of x and y, whatever it is killed, that is not a food. Okay, when I say x, that z is a peanuts, then I can say here what? Peanut is not a food, I am taking the peanut as a food. Okay, contradiction statement. Again I am proving this. I am cancelling these two. Okay, this not food and this is a food. Both will be cancelled. The remaining statements will carry out to the next statement. In the third line, no, we have the remaining. Whatever we have here, no, up to this will be carried out to the third level. Okay, this food and not food will be cancelled each other. The next, no, here we have not eat. So I have to choose, sorry, which statement is having with the eats. Okay, so I'm replacing with that. These eats and not eats are cancelled each other. Then only the killed of x or killed of y is remaining. Killed, so I am going to choose which is having the statement of not killed. So both these two will be cancelled. That not alive only will come out. Okay, if I have not alive, I am checking with the alive statement. Both will be cancelled each other. Then it is proved. Okay, hence the negation of the conclusion has been proved as a complete contradiction with the given set of statements. Okay, so this is a way how you can prove the first order logic by using the resolution method. Thank you.